How it's made, CPU. Technology in recent years has shown much progress. The CPU is but an excellent example of this creative power of technology. To know all about the mechanics of it, all you need is to check out this video, but before we begin, don't forget to subscribe to our channel. The insides of CPUs exhibit a whole range of these transistors clubbed together in a fashion that enables them to perform several functions. There are step-by-step processes involved in manufacturing a CPU. Have you ever wondered how it's all made? So, welcome back to How It's Made, and today we are going to show you all the years of engineering that have been put together to make such a masterpiece of computer processes. Step 1. Sand in the making of CPUs. Have you ever imagined sand to have any role in the making of your CPU? It sounds odd, but this has been one of the principal elements involved in manufacturing such a wonderful thing. Silicon is an essential chemical element that is required to produce microchips. Since sand contains high levels of silicon, it is needed for making the microprocessors. Silicon, specifically silicon dioxide, is the foundation ingredient involved in the entire process of manufacturing semiconductors. The sand in its original form cannot be used for manufacturing semiconductors. The process involved in extracting silicon out of it is called purification, whereby the sand has to be heated using carbon, which acts as a reducing agent in the whole process. The heating separates carbon monoxide and silicon from the sand. Step 2. The formation and slicing of the ingot. The silicon extracted by heating and purified sand reaches a polycrystalline state in which it gains certain qualities specific to creating a semiconductor. The silicon in this phase is termed electronic-grade silicon. The electronic-grade silicon produced is further utilized for the creation of single-crystal silicon called ingot. This ingot is what is used for the manufacturing of chips. Also known as boule, the ingot is monocrystalline silicon that appears in a salami-shaped bar of silicon. The ingot has a high level of purity with less than 0.1% of impurities. The ingot produced is ultimately converted to wafers. The process involved here is slicing. Slicing is done with the help of super-speed saws. The ingots are placed under these saws, which divide them into thin disc-shaped wafers. Each wafer resembles a dime-like thickness. Step 3. Wafer polishing. The wafers produced have uneven surfaces, which can lead to several damages. The polishing of wafers thus becomes important. The process involved in polishing wafers is a chemical process termed chemical-mechanical processing. The polished wafers exhibit a mirror-like smooth finish, free of any type of unevenness. Polishing also makes the wafers free of unwanted particles that otherwise contaminate it. The result is you get a better quality wafer. Dicing becomes an easy job once the wafer is free of all uneven subsurfaces, hence polishing is necessary. Step 4. Wafers are exposed to UV light. Exposure to UV light is directly responsible for creating integrated circuits as well as computer chips. UV light exposure creates geometric patterns on the surface of the semiconductor wafers and thereby makes it soluble. Before exposing the wafers to UV light, they are made to come into contact with a blue liquid which is photoresisting. As the wafer is spun at high speed, the blue liquid is gradually poured over it in a way that an even layer of the coat covers the whole surface of the wafer. A third thing involved in this process is a stencil-like substance called a photomask, which has to be aligned with the wafer. The mask contains a lens that is placed in a middle position between the wafer and the mask. Step 5. Photoresistant washing and etching of the wafer. While the exposure to UV light makes the material of the silicon wafer soluble, the same is washed off using a chemical solvent. This process is essential to make visible the geometric patterns created on the surface of the silicon wafer. Once washing is done, the next essential step that is involved in making the CPU is etching. In the case of microfabrication, etching is the process that causes the removal of layers by dissolving the substrate parts from the surface of the wafers. Etching is a chemical process done with the help of a chemical solvent. It is a critically unavoidable process. Every wafer is subjected to several types of etching before they are ready for use. Step 6. Ion doping of the silicon wafer. Ion doping is a process done to implement charge dopants or ions in the silicon wafers so that the wafers generate an electric field. There are several ways of implanting ions onto silicon wafers. It can be done either by adding boron or by adding any one of arsenic, phosphorus, or even antimony. Accordingly, the material produced is either a p-type material or an n-type material. The areas on the wafer that have undergone ion implementation appear to be green. The second round of etching is done to create 3 holes on the surface of the wafer. The holes are filled with copper, and since they are carved on the layer just above the transistor, the copper charged with electric ions helps conduct electricity to the transistor. Step 7. Electroplating the wafer and layering it. Electroplating the wafer is a crucial phase in making a CPU. The silicon wafers are electroplated by placing them in a plating bath along with a copper source. The copper source is typically one containing copper sulfate as well as sulfuric acid. This setup is done particularly to ensure that when the current is passed, copper ions will deposit on the top of each wafer. The copper thus deposited on the surface of each wafer is often in excess, which again has to be removed. The process ends up in the formation of the entire transistor. There are multiple layers connecting to the transistor. The transistors are made in such a way that they develop interconnectedness between themselves. The CPU is made up of several of these transistors, all of which are connected to each other, forming a complex yet well-connected system of circuits. Step 8. Testing of the wafer and slicing it further. The wafer produced is subjected to crucial testing to ensure its functionality. There are several test patterns set up to do away with the functional defects of the wafers. In the case of electrical testing, there remains a tester producing test signals which have to be transmitted to the wafer. The transmission is done with the help of an instrument called probe needles. The wafer is then supposed to return the signal sent to it. Failing to do so proves the wafer to be defective. The wafer then has to be sliced again. The slices are termed as dies. The dies that respond to the signal are good dies, and those which fail to respond are discarded as bad dies. The good dies passing the test are allowed to enter the next step of the manufacturing of the CPU. Step 9. Packaging the processors. The next step of making a CPU is its packaging. The packaging is not only needed for decorative purposes, but also to ensure the protection of the core of the CPU. The packaging is done to protect the processor and dies from coming into contact with any outer substances that may cause harm to them. The packaging is generally made of plastic, but they can also be made of ceramic. The outer lid of a CPU's processor contains the heat spreader. It has a dual purpose. It serves as a protective layer and also helps in regulating the heat of the processor. Since the heat spread is coated with a cooling solution, the question of the processor generating excess heat is put to check. Modern CPUs even come with a fan along with a heat spread that makes the cooling process more effective and ensures the longevity of the CPU. After packaging, the CPU is put to another round of testing. Step 10. Binning the CPU. Well, the packaging is still not the final step in the making of a CPU. It has to pass through yet another stage before finally being ready to sold off at the stores. The next step after packaging is the binning. Binning can be described as a process of categorizing the device under certain already set up criteria. The binning process involves prescribing a category to the CPU following its performance and the quality of its making. This can be stated as the final step in the establishment of the CPU. The category into which the formed CPU has to be placed depends on factors like the voltage, power consumption, operational ability, frequency, caches, and others. Several bins are formed stating certain standards. It is checked if the respective components of the CPUs are fitting to those standards or bins. The CPU can have both good chips, and mistakenly it can also have bad chips. The chips binned as high-end chips are among the best chips of the CPU. They have super high speeds. Their cache remains fully enabled. Chips with lower speed have poor performance and they are sold off. The other set of chips have almost half of their cache disabled. In the case of these chips, the speed and voltage issues are taken into consideration. The CPU after binning is the CPU that has acquired all the necessary features to be sold and purchased. It is now ready to be taken to the store since it has successfully passed all of the rounds of the test set to check its worth and performance. I hope you enjoyed watching this entire journey of the CPU with us. What is the next wonder that you want us to reveal? Do write to us in the comments below. If you have any suggestions for us, feel free to share. You can get all updates coming first to you by hitting on the bell icon. Support us by liking the video and we promise to bring you more informative videos in the future.